coming to another topic. This is acceleration of a body when it is slides down through an inclined plane. So we have seen about inclined plane how the various forces acting when a body is kept over it, and also we have discussed the angle of repose and angle of friction, etc. Right? All these things we have seen. Now let us see that when a body is coming down to an inclined plane, the motion of the body, whether it is a motion under gravity or something else, that is our today's discussion, right? So let us make a diagram that is an inclined plane. I am again making an inclined plane like this. A body is kept over it, right? This is the angular repose. Angular repose is that value of maximum value of angle theta at which the body is on the verge of motion, right? This is angle of theta is angle of repose, right? And various forces acting are like this. This is W. W is equal to mg. Weight is always acting vertically downwards, right? The body is moving down. When the body is moving down, train, the force of friction will be along this direction. This is force of friction because force of friction is always in a direction opposite to the motion of the body. We think that the body has to move down through the inclined plane. By slightly increasing the value of theta, its body starts moving down through the inclined plane. Okay. Then this force mg can be found. This is normal reaction also we will write here. Normal reaction. Normal reaction is denoted by capital R we will write. Okay. mg can be sorted into two components. One component is this one. That is mg cos theta. Always remember that. The other one is what? Mg sin theta. Mg sin theta. What is the reason? Because any vector quantity can be resolved into two components. If this is theta, naturally this also will be theta. When the body falls down, this theta becomes equal to 0. This theta also becomes equal to 0. Understand? Okay. Then it is lifted up. Then this line makes an angle theta with the vertical, and the plane will make an angle theta with the horizontal. This is the so now the body is moving down through an inclined plane. We have to find the acceleration acting on the body. Okay. So suppose the body is moving down means mg sin theta must be greater than fs. Fs and mg sin theta both are acting along the same line but in the opposite direction. You suppose that the body is sliding down through the inclined plane. Then the net force is equal to mg sin theta in the forward direction and fs is in the backward direction. Therefore, net force is equal to when the body slides, will write. When the body slides along the inclined plane, net force slides the net force, comma, F is equal to, net force, comma, F is equal to what? What? Mg sin theta. Mg sin theta minus Fs. Why mg sin theta minus Fs? Because the body is actually sliding in the direction of mg sin theta. It means mg sin theta is greater than Fs. Mg sin theta overcomes the force of friction. That means mg sin theta is greater. Therefore, net force is when two forces are acting along the same direction, same line, but in the opposite direction. Then one force minus the other force is the resultant. In this case, what is that? Yeah, mg sin theta minus Fs is the net force. But by Newton's second law of motion, net force is equal to mass into acceleration. Right? That also we can write. But one more thing, this is equation number 1 we can write. But Fs by R is equal to Fs by R is equal to mu s. Fs by R is equal to mu s also we can write. Right? Fs divided by R is equal to mu s also we can write. Mu s we can write. Therefore, Fs is equal to mu s into R also we can write. Fs is equal to mu s into R. But according to this diagram, R and mg cos theta are balancing forces. Which are the imbalanced forces? Fs and mg sin theta are imbalanced forces. Due to imbalanced forces only we have the resultant force. But these two are balanced forces. Why they are balanced forces? Because this body is neither going down nor going up. It is always on the surface of the inclined plane only. Right? Therefore, these two forces are balancing. Mg cos theta is balanced by R. What is R? R is equal to mg cos theta. Therefore, Fs is equal to what? Mu s into mg cos theta I can write. Putting this value of F first in this place, we will write net force F is equal to mg sin theta minus mu s into mg cos theta we will write. Am I correct? This is the net force. But net force F is equal to ma. Therefore, we can write what? Ma is equal to mg sin theta minus mu s into mg cos theta. This m cancel from all these terms. Then what will you write? What will you write? A is equal to g sin theta minus mu s into g cos theta. We will write. This is the acceleration. This is the acceleration produced by a body which is sliding down through an inclined plane of angle of repose is equal to theta. If the frictional force is equal to, suppose this surface is very, very smooth, then Fs is equal to 0. Then mu is also equal to 0 because mu s is equal to Fs by r. If force of friction is equal to 0 means the surface is very, very smooth. In any question, when it is seen that the surface, the body is moving over a smooth surface means mu s is equal to, why mu s is equal to 0? Because mu s is equal to Fs by r. R will be there, but mu s is, the surface is smooth means Fs is equal to 0. Mu s is equal to Fs by r, 0 divided by any quantity is equal to 0. In that condition, A is equal to, when mu s is equal to 0, mu s is equal to, remember what is that? The surface is very, very smooth. For a surface very, very smooth, mu s is equal to 0. Mu 0 in any quantity is equal to 0. Therefore, A is equal, I am writing here, A is equal to g sin theta. So this is a very important result. Understand? When a body is moving down through an inclined plane, suppose it is freely moving, there is the body is moving over over a very smooth surface. That means there is no frictional forces acting. Then what is the acceleration produced on the body is given by A is equal to g sin theta. A is not equal to g. Therefore, it is not a freely falling process. That means it is not a motion under gravity. So when a body moves down through a smooth inclined plane, prove that the motion is not a motion under gravity. If the motion is motion under gravity, then you would have proved A is equal to G. Acceleration when equal to G, then only that motion is what? Motion under gravity. In this case, we are getting only acceleration is equal to the sine theta component of T. It is not exactly equal to G. Therefore, this motion is not a motion under gravity. The actual value of acceleration is this one. That is g sine theta minus mu s into g cos theta. When mu s is equal to 0, then only we can write this one. This is for smooth surfaces. So this is one more thing I taught you. And next what I am going to tell you is, suppose a body is pulled up in the inclined plane. When a body is pulled up in the inclined plane, all these things you have to note down. It was in the board for a long time. You can note down the notes also, right? Acceleration produced. So now suppose that a body is taken up. Up means along this direction it is moved up. It is moved up. Then what is the condition? So when the body is moved up, you will see that if it is moved up by this force is moved, this is capital. It is body is pulled up by the application of a pulling force. The diagram is second diagram. What we are going to tell you is that work done. What's that? Work done in pulling up a body along an inclined plane. That is the next topic. Work done. Work done in pulling up a body along an inclined plane. Inclined plane, yes. Work done in pulling up a body along an inclined plane. This is the situation. Suppose this this surface, suppose this is A and this is B and this is C. AC is equal to S. S means distance or displacement. The body has to move over. right? Now the body is kept on the inclined plane, making angle theta, and it is pulled in the upward direction. The body has to move in the upward direction. Therefore, the force of friction will be in the downward. This is called Fk because this is the force of friction when the body moves. When a body moves, the force of friction is given by kinetic friction, Fk. So in this case, all the various forces are seen here. mg is acting vertically downwards. mg can result into two components. One is mg cos theta making angle theta, and other is mg sin theta. But the body is pulled in the upward direction. Then that means body has to move in the upward direction. Therefore, force of friction will be in the downward direction. Am I correct? So net force due to which the body can move upward is equal to mg sin theta plus Fk. If the body has to be pulled up, then the pulling force must be equal or greater than mg sin theta plus Fk. Right? So the pulling force F is equal. In this case, we can write pulling force. We will take a look equal pulling force. F is equal to what? Mg sin theta plus Fk we will write. This is equation number 1. That means we have to pull a body along the inclined plane through a distance S. For that, what is the total force required? That is equal to mg sin theta we have to overcome, and also Fk we have to overcome. That much amount of force when applied, then the body will smoothly that will move upwards. But we know that this is equation number 1. But we know that Fk, but Fk divided by capital R is equal to mu k also we can. Therefore, Fk is equal to mu k into R. We can write, right? But R is equal to mg cos theta. That is equal to mu k into what? mg cos theta also we can write. So in place of Fk, we will write this value. Therefore, net force F is equal to what? mg sin theta. mg sin theta plus mu k into mg cos theta we can write. This is the total force acting. Total force we have to apply so that the body can be pulled from this end A to the other end C. How many distance? That is equal to. Therefore, work done for this purpose, work done W is equal to force into displacement. That is equal to mg sin theta plus mu k into mg cos theta, the whole into S we can write.